So thread that blocks on a select may not be the same as the one that registers or changes interestops. Okay, so we have multiple threads dealing with data structures. Okay, so the actions may not be atomic; they may not be thread safe. Okay, concurrent programming is very tricky. People make lots of mistakes. In fact, there was an industrial person I asked, and I said, what kind of bugs do you get in your code? These are good programmers. He said the two kinds of bugs we get the most are thread issues, thread safeness, and UI issues. Okay? So dealing with UI input, those are the things that cause the biggest headaches. So, I don't know why they're not. I don't know whether this guy, the author of the Rox tutorial, is correct or not. Okay. So ideally, we should have a single thread that does select, register, and change of interest op. We don't want multiple threads to be changing data structure. Okay. And another thread can call wake up for a blocked selector thread. That's okay. But the interest op should be changed by one thread, and so that so the tutorial recommends a single selector thread in an NIO application. So far I was saying we can have one thread for selecting all grader channels, another thread for selecting all student channels, and indeed the way Java is implemented is advertised, that should work. That probably does work. I'm not sure whether he's right or not. Okay, but just to be on the safe side, we want one thread for this reason. So we'll just change this into, and so there's a more fundamental reason to have that also, that we have a code duplication problem here. The student thread and the grader thread do the same thing, except on unblocking they do different things with the read data. Okay, so that to me is a more interesting problem. What the Rox tutorial says is probably a transient problem, if it really was a problem. This is a more interesting problem that I want to combine these two threads into one. So software engineering hat, how do I make sure that I can just have one thread, yet have application specific processing of the events?
Register a different class for different events.
So register, and what kind of class would you call that? Command object, listener, what would you call it? So command is the answer that I provide. Why not just say, just register listener? Sorry?
You're listening for a specific event. It's not
Yes. Okay. So we show a single thread that selects, register, and changes interest op. And what we have is application-specific pre-select code. Okay, so before an operation is to be done, you want the operation to be enabled, right? We want the interest op for that. That is application-specific. We want to connect, so that's at least operation-specific. And we want some application-specific post-select code also. Okay, so we need some application-specific code to be executed before the select is executed to sort of change the interest op, because we don't want to change the interest op in our threads. That's maybe thread unsafe. So we want to change that in the selector thread, and we certainly want application-specific code after the select code. Okay, and so application-specific post-select code is executed after select and pre-select before the select. So how to test a thread about the pre and post-select specific application code? And sort of which threads execute this. So these are issues that the NIO doesn't answer. Okay, these are issues that the Rox tutorial tends to answer a little bit. And these are the questions that are answered by the layer I put on top of it. So this is not NIO. NIO stopped 2 slides ago with the problems I mentioned. Okay, and how you deal with them, you read the tutorials, you figure out what to do. That was the end of NIO. Now we are trying to do something above that and try to understand what to do. And the Rox tutorial has an implicit design pattern, and whether it's good to put another layer on top is an issue of debate. So whenever we put a layer on top, we are sort of choosing policy and saying this is how things should be done. Whenever we don't put higher level layers, we are saying we are focusing on mechanism, and mechanism means you can do whatever you feel like. Okay, so NIO basically what I'm trying to say in a long-winded way is, I'm going to give you something on top of NIO, and you might think that, oh, NIO was designed badly, and that's why I needed to add on top of it. What I want to say is that NIO is much more flexible than the layer I'll give you. So I've chosen a particular point in the flexibility abstraction trade-off, and NIO has its purpose, and the layer on top of it has its purpose. And sometimes the layer will, most of the time, the layer will probably suffice, but when it doesn't, you need to know NIO also. That's why we've gone through and studied NIO in such great depth, so that we have the flexibility also. Okay, so it's a mechanism versus policy thing. So we need layering. So how to tell Selector thread about the pre and post select specific code? We could have registered observers that are called before and after. Okay, but here's the difference, and this is somewhat philosophical, but it's, I think, subtle. An observed object doesn't ever depend on the observer to do something. Okay, it just says, hey, something of interest. I don't need you. I'm in a lower level layer, and I don't depend on you. And we can have no observers, or we can have one observer, or we can have n observers. Okay, that's not quite what's happening here. What's happening here is that we need something specific done. We need the interestops to be changed. We need the operations to be read, and so we can have 0 observers too. So the notification method is supposed to be informed about actions, not perform actions on which we depend. Okay. So what we'll do is have command objects. That's the long answer to what you've seen already. Okay. We'll have command objects. That's future processing. We've seen command objects earlier. The command objects earlier we saw had only the execute method. Okay, but now we need something to be executed before and after select. So I'll have add another method to this, which is not just execute, but we'll have we need to do something before the select call, like register connect interest offer channel, call connect, set write interest offer channel. Okay, we know whether we want something to be read or written or not, so we'll go and set these things. Okay, so this is the example of pre and post select operations. Register connect interest off for channel, call connect, set write interest off, call finish connect. I guess I got it twice, and call write on channel. Okay. Oh, call finish correct on channel 1 and 2 is what I'm probably saying. This text makes no sense. Okay. Okay. So I'll have both an execute and an initiate. Okay. So that's what's happening. That you have an initiate operation and you have a execute operation. Okay. Way back, you told me that I looked at your accept command, and it calls execute only once. It calls initiate only once, and calls execute multiple times, once after each accept. Okay, so that's why you have these two operations. Okay. So command object enqueued by in a bundle buffer by producer thread and dequeued by consumer thread. Okay, so what we're going to have is these command objects that are enqueued. Some other thread will go and say, hey, selector thread, do this for me. The selector thread will do it. So we make sure that these operations on shared objects are done only by the selector thread. We just go and tell the selector thread to do our operation. We don't do it ourselves. So we don't have concurrency. Plus, the selector thread can be generic, and it can do something that we want done, rather than something it chooses. Okay? Questions? So that's how command objects fit in. The command objects are the ones that are registering for operations. You didn't have to call register interestops, but you had to tell the command objects what kind of interestops you want to some degree. Okay, we'll talk about that. So what we do is we enqueue operations for the selector thread. Whenever the selector thread dequeues one of these command objects, it'll do it serially. It'll call the initiate method on it. Then it'll call select based on whatever interest ops got executed by the initiate methods. And after select, it'll go and call the execute method on relevant command objects. Okay? So initiate is called before the select, okay, when the object is dequeued, okay, once when it's dequeued. Then the select is called, then the post select operation is executed by calling execute, okay, and that's sort of the way it goes. So execute method when executable. And we're going to now have, for each kind of operation, we'll have a different command object. We'll have an accept command object, a read command object, a write command object. You guys have seen that. You use factories to create some of them. And each of these will be in a separate queue so that the select thread can do operation-specific processing of these guys. Okay. So that's the structure. That's kind of the structure in the Rox tutorial also. It's kind of, not quite. This is the exact structure. I mean, this is sort of abstracted out in my NIO manager. Okay, going a little fast here. There's some more details. The concepts we've seen, command objects we've seen before. We've seen the notion of unblocking. This is just okay. So what's interesting is the following: that we have an NIO manager, and then we have an NIO interface. On top of that, I've added an NIO manager interface, which has these properties. It supports command objects, and the command objects can be whatever we want them to be. Okay, so we have flexibility, and what we are seeing here is that a new program. What does this ladder here mean? Why did I ladder these layers? It's not a full cake.
APIs are getting bigger and bigger. There's more functionality.
So as you go higher, the set of API gets larger. When you say bigger, you mean the bigger as you go down or bigger as you go up?
Well, here you've drawn it bigger as it goes down.
So what is, yeah, so why did I draw, yeah, so, yeah, the size of the API is kind of misleading here. I can see why you're saying that. Green is sort of the code I write, red is what is given to me, yeah.
I was going to say it's by flexibility, so
So the most flexible is at the bottom. And the point is that the NIO manager has not hidden the layer below it. You can use that layer also. So I can put my green box, which is me, the programmer, on top of the NIO manager, or I can put it on top of the NIO in interface, or I can put it on top of intra processing. So we are abstracting out, and what when you do it this way, you see that if I put it on top of the NIO manager, my code becomes small. Height is small. If I go and put it on top of NIO, it becomes taller because I'm dealing with a lower layer. Okay, so then we are not hiding; we are just layering on top. So client threads use special singleton NIO manager. You're going to make the NIO manager is singleton to enqueue command objects and wake up select thread. Okay, and unblock, does this. So we've gone through this already. So unblock select thread invokes initiate methods of enqueued command objects, and initiate method may do the following, and execute may do the following. Okay, I have to go and change some of this text. And we can do a little bit more refinement. As it turns out, we won't need per channel more than one accept command objects. A channel is accepted only one. The different command objects would do the same thing on a particular channel. So we don't need different accept commands for the same channel, because we'll be doing the same thing, basically creating a connection, executing accept on it. So there's only a single command per channel needed for accept and connect on a channel. Okay. At most one connect command needed a single time. Okay. And we expect same accept processing. We'll create a single NIOManager buffer for reads on a channel. So we also need a single read command object. We don't need multiple read command objects. We'll just use the same buffer again and again. Okay. So that reduces copying. Okay. And we'll create multiple command objects for different writes, because we want to write on different buffers. Okay. And here's an interesting thing that's in the Rox tutorial, I believe. He says don't mix reads and writes. That means if you're in the process of writing, for instance, write the whole data before you do any reads. Don't say, okay, I've written part of the data, now let me go and read, now let me write the rest of the data. Why do you think that's the case? Why do you think that might be good?
Simplicity. Take a lot more code to manage, like keeping track of where you went to.
Okay, simplicity of code. Because you have to keep track of how much you've read and how much you've written. Actually, what he's saying is the following, that if you have multiple writes, so one thread said write this, another thread said write this. They've both been queued up. Do all the writes at one time, rather than try to read in between. Each buffer is separate, so we don't, we have to keep track of the pointer anyway, because we're never guaranteed we can write everything. But he's saying, when you're in the write mode, just write everything. Think efficiency.
You're not going to have to switch back after you. So if this goes back to them being able to accept the threads, it's a lot less.
So context switching perhaps is less, but this is all being done by one thread. Yeah.
Then the volume of select method for not needing to stop and start the blocking all the way.
So that is true, that okay, let me rephrase what I'm saying. Supposing at one time there are 10 writes enabled and 3 reads enabled after the select operation. So we are not going back and invoking select. I have 10 writes enabled and 3 reads enabled, and he's saying do all the 10 writes, then do the 3 reads before doing the select call. Yeah.
Maybe just you download all the dry commands and send it at once, so it's saved at 10 times.
So you send all the data at one shot. If there are 2 different threads writing to the same channel, you're sending the data in one packet rather than sending it in multiple packets. Also, he just believes that the code works more reliably this way. Okay, so he's very skeptical about the code, and he said, don't. He doesn't give this reason. He just says that don't do it. Trust me. And he also, I think, believes that it just mixing these 2 operations makes things a little flaky. Okay, so we do the same thing. So it reduces scattering of writes into different messages and implementation bugs. Okay. Now, I seem to indicate that the green is the code that we have to write. And I indicated to you that this picture seems to indicate that we write the command objects. But you guys didn't write the command objects. You use the command objects. Okay? That's because there are certain things we can sort of expect. I mean, the typical things that do happen in command objects. And why not provide a predefined set of default command objects that you can change through factories, okay, to give you even more flexibility. Okay? So So the question is, what do these do? And I've kind of, this particular slide I've duplicated so many times, so I've duplicated the mistake on it also multiple times. So if I want to change it, I'll have to go and change all of them. So we know that certain things do happen, that after write, when you want to do a write, you want to enable the write before that. When you do a connect, you want to send a connect message, and then in the post operation, you want to go into a finish connect. You might want to do something esoteric that was not anticipated, in which case you can define your own command objects, but there are certain things that happen regularly, so why not just provide you with default command objects also? Okay. So now, and then, but the thing is, not all code is default. After the read, you do want to go and process the read in a very application-specific fashion. So we'll go back to a listener idea. Okay, so this is getting a little complicated, but let's see if you can get this point, that's the main point. So there are some things that we expect to happen before the select, like changing of interest op. There are certain things we do expect to happen after the select, like reading into a buffer or writing the buffer. Certain other things we expect to be application specific, like send a message to the grader, send a message to the client. So what we do is we break the application specific code into the command object code and listener code. Okay, so the command objects will now have listeners. The selector calls command objects, the command objects call listeners. So we sort of get to do the regular things happen in the command objects, the typical things happen in the command objects, and the atypical things happen in the listeners. If you want to, you can make everything happen in the command objects, in which case you use your own command objects. But if you want to have default command objects, then you have to register listeners with the default command objects to do application specific functionality. So I originally said, we've got listeners, or we can have command objects. There are two alternatives. We can combine these two things together by saying we have command objects and they have listeners. And these command objects are the default command objects. That's why they don't have application specific functionality. So to add application specific functionality, we'll have listeners. So rather than giving you the whole design at one shot, I'm just giving it to you in layers to sort of show that I'm reducing flexibility in stages, and you can go and get the one you want. Okay. So questions on that? So command objects inform registered observers after they execute. Okay. So this is now my new stack. Okay. If I want to, I can write my own command objects on top of the NIO manager, or I can just add command listeners to the command to the default command objects. Okay. So that's what you guys had. But I do want you guys to know the whole layer, all the layers underneath also. Okay. So how to switch among command classes? You've seen that we have factories to do that, and we'll create the commands through the factories, and you can add your own factories. Okay, so we have now, this becomes concrete. So I have, for instance, my connect command factory here, and we see that it has a lot of arguments, and one of these arguments is an interest op. And so what does this interest op say? At the bottom, you guys have used it in your assignment. What is that interest op argument? This is the connect command factory. So it's saying what?
It's the interest operation to wait for on that channel after the connect is accepted.
So once the connect is done, what interest op should be registered to the channel? Okay, so we automated that. I mean, that's typically what will happen. You either want to read or write or whatever. Just pass it as a parameter. So application specific functionality is accommodated by either having listeners or passing appropriate parameters to the constructor of the command objects. Okay, and in this case, in the case of connect, it means what operation should be enabled after the connect. Okay, because after the connect is going to do a select on that channel on that, and we want to know what to block on. Okay. So I guess my animations are a little off here. Okay. So let's go and see what the predefined except command does. It takes as a constructor. That was just an example factory. I guess I'm now going through and telling you exactly what these command objects should do. I've got 3 minutes. I'm trying to see whether I should wrap this up in 3 minutes or just. So let's just do it next time. Okay. It's all details now. I can do it quickly, but why do anything in a rush? So fill in your diaries. Finish your second assignment in 3 minutes.